Chapter 14, Acids and Bases, Section 14.1, Acids and Bases. Video problem 79 follows. Check it out. All right, so here we're going to be talking about the simple definitions of acids and bases. All right, so the first definition, we're going to see two definitions. The first definition is an Arrhenius definition. And the Arrhenius definition is a fairly strict definition. In other words, it's the most narrow that we have. So for an Arrhenius acid, it's anything that donates a hydrogen ion. Okay? So in other words, this HCl, which let's say it's a gas, I bubble that up through water, it's going to give me H plus Cl minus. So that's an acid. Okay? Because it gives an H plus. Now H plus obviously has to be aqueous because it's an ion. Ions can only exist when they're aqueous. All right? All right, so let's talk about naming these acids. All right, so there is what's called the binary acid. The binary acid is just going to be hydrogen plus some element. Okay, now the element's going to be a non-metal. So whenever you have a hydrogen plus an element, it's always named hydro element ic acid. So, you know, I just looked at HCl, so HCl is hydrochloric acid. Okay, but hydro comes front. HBr, hydrobromic acid. So again, the hydro lets you know that it's a binary acid, just hydrogen with another element. Okay. Now the other types of acids we'll take a look at have polyatomic ions in them. Okay, and these are often called oxyacids or something to that effect. And basically, if the polyatomic ion ends in an 8, then we change 8 to ic acid. Okay, so here's, well, this is a bad example. Here's sulfate. Well, we call this sulfuric acid when we add hydrogens to it. So H2SO4. We add 2 hydrogens because we have a -2 charge. Let me show you a better one. This one, C2H3O2 minus. Okay, that is the acetate polyatomic ion. So the name of the acid, which would be H, C2H3O2, would be acetic, H changes to ic, acetic acid. Okay. Now, the other form is ite. Ite, we change to us. So sulfite, which is SO3 2 minus, becomes H2SO3, which is sulfurous acid. Okay? So that's naming acids and bases. Don't worry about this carboxylic acid stuff. And then just a few properties of acids that you probably already know. They have a sour taste. They change blue litmus to red. What does that mean? That means that there is this paper, litmus paper, and it's blue litmus paper. And when I dip, or when I put a little bit of acid on it, it turns red. That's what that means. That lets me know that that's an acid. All right? And then it will corrode some, not all, metals. Luckily, it doesn't corrode copper, because then every time you swallowed a copper penny, you would be in some serious pain. Right? Because you have acid in your stomach, in your tum-tum there. Right? So that's acids, bases, a little bit easier. Again, we're going with the Arrhenius definition at this point. So in the Arrhenius definition, a base is anything that gives off a hydroxide. So like sodium hydroxide, when I throw that in water, that's a base, because it gives off the sodium ion and the hydroxide ion. All right? So that's a base. And all your bases, since they do have hydroxides, we already know how to name these. They're just all hydroxides. Nothing fancy there. Okay? Mostly talking about group 1 and group 2. Okay? What are some properties of strong or bases? They are strong electrolytes. They have a bitter taste. Think soap. Also think a lot of your greens are are bases. Okay, they're alkaline. They feel slippery, and they will turn litmus blue. So you have this pink litmus paper, red litmus paper may be called, and whenever you put a little bit of base on there, it'll turn blue. Okay. And then also phenolphthalein, which is a common acid-base indicator that we'll talk about and you'll use in the lab. Okay. It'll turn phenolphthalein pink. And we'll talk about hows and whys later. Okay, so those are just some general properties of acids and bases, how to name acids and bases, also Arrhenius acid and base definition, and so 14.1.